Hi gang, this is 1.9. 1.9 is inverse functions, and an inverse function, you can think of it as like an opposite, okay? Let's think of opposites. If I wrap a present, if I wrap a gift for you, the inverse would be for you to unwrap it, okay? If I add 5, what would the inverse of adding 5 be? Good, we'd subtract 5. If I divide by 2, the inverse would be to multiply by 2. Good, so what we're going to do is we're going to find functions that are inverses, so they're opposites. When the functions are basic, you can pretty much see what the inverse will be. As the functions become more complicated, it's more difficult to see what the inverse is. It's not as straightforward. So before I start, let me just go over some definitions. Again, I do not ask definitions on exams, but you really want to understand what the language is so you understand what you're being asked, and also so that you just can communicate accurately what you're trying to say. So let's go back over this, and I did this at the beginning of the week. We talked about a relation. A relation meant that there was no rules to how X and Y were paired. So what again I'm saying is that there's no rules to how the domain and range are combined. When I say X and Y, I'm referring to the domain and the range of the function. Okay, so there's no rules to how the domain and range are combined. Then we talked about a function. A function had one rule, and that rule was each X goes to exactly one Y. So whereas this is level 1, this is level 2, we're getting more sophisticated. There's a restriction to what things are functions and what aren't functions, because if an equation doesn't satisfy this condition, it's not a function, it drops down to being a relation. So if something classifies as a function, it means each X goes to exactly one Y. And remember, graphically, it would have to pass the vertical line test. Now, if we go up to the third level, if this is level 1, level 2, this is level 3. Level 3 is when you have what we would call a one-to-one function. So it has to have the previous rule, and it has an additional rule, right? Because it's more sophisticated. We're going up the hierarchy here. So again, it has the previous rule, and the new rule is that each Y goes to exactly one X. And graphically, that would have to pass the horizontal line test. So what this means is that if a particular function has an inverse, it must pass the vertical and horizontal line test. If it does, then that candidate, that equation, can then have an inverse, all right? So just make sure you understand what this means. So the only type of function, the reason why I'm going over this, and this is the important part, the only type of function that has an inverse is a one-to-one function. It's the only type. This special exclusive club of one-to-one functions is the only type that has the other side of the coin, so to speak. It has the flip. You can find an inverse of it, okay? Only this case. This one does not, and this one does not. These do not have inverses, these do not have inverses, but this category has an inverse, all right? So if you're one-to-one, it means that you can find an inverse of that function. All right, I think I'll keep the first video here just a little bit shorter, but let's just cover one more thing before we go ahead and start another video. So if the graph has an inverse, it must pass both the vertical and horizontal line test. So what I did here was I gave you two functions. Okay, I might just need to grab another pen here. Okay, I gave you two functions, and I want to know if the function that you're looking at has an inverse. Does it have an opposite? So in order for you to tell if it has an opposite or not, you have to test it. You have to see if it passes the vertical line test. Would you say this one passes the vertical line test? It does. Good. So it passes the vertical line test, but it also must pass now the horizontal line test. So you have to do both. And let me just see what other You can see I like my fun color collection here. All right, let me see here. And does it pass the horizontal line test? Horizontal line test means it can only touch the graph once. Would you say it passes that? Yes, yes it does. So it passes both, which means that f of x has an inverse. So yes. Yes, this particular guy here, this guy has an inverse. This guy has an opposite. It passes both of the tests. All right, now let's look at this guy. Again, when you're doing this, when you're trying to see if something has an inverse, you have to do both the vertical line test. Okay, does that pass the vertical? So the vertical line test just tells you it's a function. The vertical and the horizontal line test tell you if it has an inverse. Now, does this pass the horizontal line test? Right? Heck no. Right? Heck no. Because I wish I drew this a little more symmetric. Let me see if I could just improve that. So let's say that let's say this is the point 2, 4, and let's say this is the point. Just because some people are very visual, I can help them a little better with visual. Let's say this is a point -2, 4. So the problem is, and let me find my notes we just wrote, and of course they're missing in action. Oh, no, they're right here. Okay. The point is that each y goes to exactly 1x, okay? So for this height, for this particular height right here, this height of 4, it has 2 different x values. It has 2 different x values, okay? So remember that schematic I was drawing the other day when we were going this way, like this? When you do an inverse, it has to go both ways now. You're not just looking at it like this way, making one choice. You also have to look at it now this way. Because now this way, this 1y is going to 2 x's. Now this guy on this side gets to go to the ice cream store. And when this guy goes to the ice cream store, you can't have 2 picks. So this is more complicated because you have to look at the schematic going this way and going this way. So going this way, it fails. You have one y value that has 2 x's. And if that happens, this guy has no inverse. So no inverse. Okay, this guy, as stated, has no inverse. Now this can get, I'll just make a quick side note here if anybody's interested. Oh, hopefully you're interested, but you know, we all have those days. So the thing is that this function, this parabola, has no inverse, as we just went over. So what you can do is you can do a restriction. And there's a zillion restrictions I can make on this graph. I'm just going to pick one. Okay, there's a zillion restrictions. I'm going to restrict the domain to be x is greater than or equal to 0. And if I do that, if I force this parabola to have a restriction, now I only have this part of it because I said, okay, I'm only going to take the domain greater than 0. So I'm going to get rid of all this. I'm going to get rid of all this. And then under, oh my God, I'm piling up in this table here. And under that restriction, it just looks like this. And now, would you say it passes the test? It does, right? So under this restriction, this segment does have an inverse. And you'll notice as we go through the course that sometimes a function that would not typically have an inverse is chopped up to a segment that does. And then we find the segment of that inverse. Okay? All right, I hope you understood what I just said there. I will catch you again in another video. Bye-bye.